Hi, this is Algebra 1, 2-2, Lesson 2-2. In Lesson 2-2, we're going to learn about point slope form. 2-1, last lesson was about slope intercept form. And today is going to be another form called point slope form. After this lesson, you will be able to write and graph linear equations in point slope form. Also, you'll be able to analyze different forms of a line to interpret the slope and y-intercept of a linear model in the context of data. Okay. So let's review the vocabulary we had last lesson, slope-intercept form. It was a linear equation form where you had y equals mx plus b, where your m is your slope and b represents your y-intercept. Today, we will learn point slope form. Let's look at critique and explain. Paul and Seth know that one point on a line is 4, 2, and the slope of the line is -5. Each student derived an equation relating x and y. Paul came up with an equation y equals -5x plus 22. Seth came out with an equation -5 times x minus 4 equals y minus 2. Do the two equations represent the same line? Construct a mathematical argument to support your answer. Well, they look different, don't they? But are they the same line? Do they have the same slope? Do they have the same points? Are the questions that you will ask. Okay, so look at Paul's work. Do you think Paul's work is correct? Paul has a slope of -5 and a y-intercept of 22. And Seth also has a slope of -5, right? You don't know the y-intercept, but you could solve for it, where y-intercept is when x is equal to 0. So you can set x equal to 0 and see if they have the same y-intercept. Or you can graph both lines to compare them. But that's 20 plus 2. And yes, that's 22. Is that the same? Yes, they have the same y-intercept. They have the same slope. Thus, they should be the same equation. Let's write that down. Okay, they have the same variables, x and y, the slope, and the same y-intercept. So they are the same equation. Seth's equation is based on the slope formula, and it's undefined when x is equal to 4 because you can't divide by 0. But Paul's equation is written in slope-intercept form. Okay, part B. Let's make sense of this problem. Generate a table of values for each equation. How can you reconcile the tables with the equations? Let's make a table. So for Paul, you're gonna generate table of values. If x is 0, if you plug in 0 here, you will get 22. If it's -1, -1 times -5 plus 22 is 22 plus 5, which is 27. 1 is -5 times 1 plus 22, which is 22 minus 5, which is 17. Okay? And this is called the table of values. And so on. What about Seth? Is it going to give us the same values? Plug in 0, we have 22. Plug in -1, 27, 1, 17, 2, 12, and so on. So what does that tell you? Because the equation represents all the points on the line and does not have a point where the equation is undefined, we know that the equations are the same. Okay. So let's write that down. The tables show that Seth's equation is undefined at x equals 4, but the inputs and outputs are the same for other values. So in this lesson, we are going to think about this question. What information does the Poisson form of a linear equation reveal about a line? So today we're going to learn about the Poisson form and the information that it gives us. Let's look at example 1. Understand Poisson form of a linear equation. Part A. How can you write the equation of a line using any points on a line? So if you're given any point, we're going to represent a point using x comma y. Okay. And specific point x sub 1 comma y sub 1 means that's point 1. Okay. And there's going to be another point called a second point x sub 2 comma y sub 2. That is going to represent the second point. And your slope equation tells you that you get a difference of the y values to get a change of the vertical line, right? The vertical distance. And you get you subtract the x values to get a change of the horizontal distance, and that is your slope. And so let's just plug it in with our variables. We're going to define x comma y as any point on the line. So we're gonna substitute y sub 2 and x sub 2 as x's and y's. Okay. And then we multiply the denominator, which is x minus x sub 1, on both sides of the equations, and we get rid of the denominator here. And so you have y minus y sub 1 is equal to n times x minus x sub 1. So switching the sides, they're still equal to each other. Equations are the same if you flip the sides, it doesn't matter. So y minus y sub 1 should equal to m times x minus x sub 1, and that is your point slope form. All right, so any point, if you have any point of a line, you can write a point slope form, given that your slope is given as well, okay? Why is it helpful to have a point slope form in addition to slope intercept form? Why not just use slope intercept form? Using point slope form allows you to write an equation of the line without knowing the y-intercept. Sometimes it takes too much time to figure out y-intercept. You can use any 2 points on the line to write the equation. No, just right away. Okay, let's try number 1. Describe the steps needed to find the y-intercept of the graph using point slope form. Okay, think about it for a moment. Look at example 1 and describe the steps. Okay, looking at example 1, you're going to use any point in the slope to write the equation of the line in point slope form. You're going to substitute 0 for x in the equation to find the y-intercept if you want to. Let's look at example 2. Write an equation in point slope form. Part A. A line with a slope of 1/2 passes through the point 3, -2. You have a given point. You have a slope. What form can you use to write the equation of the line? What is the equation of the form? Okay. Yes, you can use the slope intercept form, but what is an easier way with this given information? It's the point slope form. You literally have a point and a slope. That's why it's called a point slope form. If you have a point and a slope, you can write a point slope form right away. So you have a point slope form Here, y minus y sub 1 is equal to m times x minus x sub 1. You're going to substitute the x value and the y value from the point, and you're going to substitute 1/2 for m, which is your slope. And that's it. That is your equation. Y plus 2 is equal to 1/2 times x minus 3. Don't forget the parentheses. Okay, that is going to be your equation in point slope form. Part B, what is the equation of the line that passes through point -1, 1 and 2, 3? Now we don't have a slope, but we have 2 points. Can we figure out a slope using 2 points? Yes. Look at the slope equation. Second point, the y value of the second point minus the y value of the first point over the x value of the second point minus the x value of the first point will be your slope, which is 1/3. Okay, now that we have a slope, just pick any point from these two given points. It does not matter which point you pick, but make sure you plug in the correct x and y corresponding to the point. Okay, so the textbook chose 2, 3. You're going to put 3 instead of y sub 1 and 2 instead of x sub 1. Your equation in point slope form is y minus 3 is equal to 1/3 times x minus 2. This is also the same as y minus 1 is equal to 1/3 times x plus 4, because if you choose that point, that will also be a point slope form. So what do you notice now? There are many, many answers to point slope form. Even if you simplify, there are many, many answers because the points are going to be different. But the key is that they are still the same line because they have the same slope and they have the same y-intercept. If you graph them, you will get the exact same line. Okay, just be careful to substitute the x and the y coordinates from the same point, not mixing them out. Okay, try number 2. Write an equation of the line that passes through 2, -1 and -3, 3. First step, find the slope. Second step, pick a point. Third step, plug it into the point slope formula and you get a point slope equation. All right, if you figure out the slope of the line by subtracting 3 minus -1 and -3 minus 2, or you can switch the order and say -1 minus 3 over 2 minus -3, you will still get the same slope. Okay, 3 plus 1 is 4. -3 minus 2 is -5. So your slope is -4/5. That's your slope. Pick a point. You can choose the first point and say that's y plus 1 because it's y minus 1, right? Is equal to -4/5 times x minus 2. Or if you picked the second point, you should get y minus 3 is equal to -4/5 times x plus 3. Okay, either equation should be correct. Example 3, sketch the graph of a linear equation in point slope form. What's the graph of y minus 3 is equal to -2/3 times x plus 1? Step 1. First, you're going to identify a point on the line, any point on a line from the equation and plot it. Okay, how do you find the point? You're going to substitute values. Or if you look at your y sub 1 and x sub 1 values, they tell you a point because point slope form already has a point in the form, right? So your point is made up of -1, +3. Okay, so that's a point and your slope should be -2/3. Step 2, use the slope to plot a second point. So starting from -1, 3, you go down 2 and go over 3 on the right, and that should be your next point, 2, comma 1. Okay? Sketch a line through the points to get a line. All right? So just make sure that your point slope form, because your point slope form is originally y minus y sub 1, m times x minus x sub 1, you get the negative number when it is possible, right? So y minus 3 means you're subtracting the positive number. So your 3 is going to be your y. If you have plus 1, that means you're subtracting negative 1. So you have negative 1, okay? Let's try number 3. Sketch the graph of y plus 2 equals 1 over 2 times x minus 3. So first, you need to figure out a point. From this point slope form, what's the point that you can get easily? Your x is going to be positive 3. Y is going to be negative 2. That's your point. Your slope is 1 over 2. So in your graph, you're going to plot 3 comma negative 2. Okay. And then you're going to use your slope. Go up 1 and then go over 2. Okay. They're both positive. So this is your next point. Go up 1 again, go over 2. That's your next point, right? So if you want to draw more points, that's fine, okay? But that's your 3 comma negative 2. And then you have 5 comma negative 1. You have, you have 7 comma 0, okay? Plot your points. All right, moving on to example 4, applying linear equations. Let's look at a real world problem. An event facility has a banquet hall that can hold up to 250 people. The price for a party includes the cost of the room and room rental, plus the cost of a meal for each guest. Marissa is planning an event for 75 people. She has budgeted $1,200 for the party. Will it be enough? Let's look at the graph, okay? She's planning an event for 75 people. 75 should come between 50 and 100, right? And she has budgeted 1,200. That's going to be about here. Is this going to be enough? Okay, is this point on the line? Fantastic yeses. Okay, total cost versus number of guests. Okay. Determine which form of linear equation is more useful. Are you going to use the slope-intercept form or are you going to use the point slope form? The number of guests and the total cost represent different data points. So the point slope form is more useful. We have the points already, right? So we're going to use the point slope form. First, look at the slope. The slope represents the cost of each meal. Use the 2 points, 50,725 and 100,325 to find the slope. Okay, 1,325 minus 725. Those are the y values of the point. Over 100 minus 50. Those are the x values. It's going to be simplified to 12. The slope is 12. So every number of guests, the total cost increases by $12. So each meal costs $12. Okay. Use the point slope form to find the cost for the event for 75 guests. Okay. You're going to plug in the slope and then you're going to plug in, you're going to get 1 point. You're going to just pick a 1 point. You can choose any of those points. Okay. For this example, we chose 50,725. So that would be our equation. But you're going to substitute 75 for the x value because you want to figure out this point. If x is 75, what would y be? That's what we're trying to solve from the equation. Okay, this is the final equation. But we're substituting 75 for x so that we can solve for the cost y. So solving for y, we get 1,025. So when x is 75, y is 1,025 in this line that we have. Okay, the cost of the event for 75 guests is 1,025. Is that gonna cover? Is Marisa gonna cover that? Right? She budgeted 1,200, and that should be enough to cover 1,025. So she will have enough money, is the conclusion. Okay, that is the interpreting part. So if you have a word problem like this, formulate a plan, compute, and solve for your answers, and interpret your data, and write your answer in a full sentence. Let's try number 4. Rewrite the Poisson form equation from example 4 in slope-intercept form. What does the y-intercept represent in the terms of the situation? So let's rewrite the Poisson form in slope-intercept form. How would you do that? Well, what does slope-intercept form look like? Remember, y equals mx plus b. We want to isolate the variable y. So if you have this equation of Poisson form, y minus 725 equals 12 times x minus 50, you just want to isolate y and simplify your equation so that you have mx plus b on the other side. So let's add 725 on both sides, and then you isolate y right away. But what do you have to do? That still does not look like the slope-intercept form. You need an mx plus b, right? 725 is not going to be your y-intercept. Let's solve by using distributive property. Y is equal to 12x minus 50 times 12 is 500, 600, yes, 600. And plus 725. You simplify, y is equal to 12x plus 125. Okay, that is your slope-intercept form. What does the y-intercept represent in terms of the situation? The y-intercept represents the cost. Well, it's represented by the number 125, but the y-intercept itself here represents the cost of the room rental. Okay, that was try it number 4. All right, so let's summarize the lesson. What did we learn today? Poisson form of a linear equation. The Poisson form of a linear equation is useful when you know the slope and at least one point on the line. And it looks like this in algebra. If you plug in some numbers, you have some examples. Okay, 2, 4 is a point, and you have a slope of 3/5. So that is your slope, and that is your y value of your point, 1 point, any point, and that is your x value of that same point. Okay. All right. That was lesson 2 dash 2. Point slope form. All right. Bye.